Okay, so since my thing is about to die at some point, we're going to do part C because it has more writing with it. And let's just copy paste this. Oh yeah, as you can see, I have my secondary angle. I'm gonna like go with my, you can see everything right here. This is my OneNote that I'm gonna be writing on. This is my face over here. So okay, scared me because I saw my phone go blank because I went to my OneNote on there. Okay, so derive matrix vector equations through minimization of some square error least squares. Between model and linear combination of basis vectors show that you obtain the same results as in part A. So let's write down what we got in part A again. So at the end of that one, we got V1 vector dot product U1 vector. So our dependent times our independent value vector, and then two independent value vectors. All right, this is what we're trying to obtain. Now what we're going to do is use another equation from that one. So that was the E vector is equal to the V1 minus C1 times our U1, which is our independent. This is our dependent, which is the V. And oh no, it died. Wait, maybe I can pause and then grab the iPad. Well, my Surface Go 3 died, so we're going to do things with my mouse on this OneNote. Okay, so we have this. Oh, wait, this is not drawing. Okay, so we have this. What we're gonna do. Oh, that's great. Oh no, I did that. Apparently the eraser doesn't work. Cool. All for the two angles. Okay, so we're gonna square this. So you're gonna get pretend that's a vector sign. Oh my goodness. Okay, so your dependent variable minus, and we want to do a summation so we can minimize our error. I'm moving down. This is ridiculous. Okay, I'm moving down. It's okay. Wait. Okay, the eraser does work. I'm just okay. So what we're gonna do is we're going to have the vector v, right, or dependent variable minus summation to minimize our error, and then we're gonna have our coefficient times our independent variable u, right? And we're gonna dot product this with itself, right? And so oh, I'm gonna get carpal tunnel doing this. Okay. V minus summation of C1 dot product to U1. Okay. And eventually we want our sum squared error like be equal to 0 to minimize it, right? So obviously, well, actually, we want the derivative to equal 0 to minimize it. So let's do like derivative sign that looks kind of like a note of e squared over. I'm going to do this with the variable I instead of 1. But really quickly, I actually have to go do something. Hey, when I talk for a really long time, my mouth gets dry, and so does my throat, and then I'll start coughing. And I don't think you'll want to hear me coughing. So we got the Sprite. Okay, so also, I'm gonna kind of do a little bit over again. We want it from I is equal to 1 to n. This is so beautiful. It reminds me of transport 1. Okay, and we're actually just going to do the derivative stuff afterwards. So what we're going to do is we're going to actually distribute this, right? And so what you get is your e squared is equal to v squared minus, I'm going to have 2, and then, ooh, that looks, just going to leave it. The summation, I is equal to 1. Oh yeah, I should probably just take this away because my account won't sign into it. Okay, so in, and then Am I doing? Oh yeah, v times that, a times that. Okay, so my laptop is dying. I'm gonna plug in. Okay. Yes. Okay. So let's make sure that it is plugged in. Okay. So CI UI. Did I? Did I? Okay. So then, positive or negative equals positive, right? So then, since we have like 2 things of this, we're going to use your variables. Oh, you can see me turn in that one, but you can't see me. We're going to use your variables. You use P and you use Q. So, let's do CP, CQ, dot product. Okay, that was ugly. Wait, I can just redo. There we go. There we go. Then UQ. Oh crap, I forgot my other sigma. Just remember, just Q is equal to 1. Let's go, guys. All right. So, hey, what does this do? Never mind. I might cut that out later if I can figure out how. Okay, so basically this is the e squared, right? But we want to minimize the derivative. So we're going to take the derivative of this, the e, with respect to our coefficient, but with a j variable, which we will talk about why later. This is the most uncomfortable setup ever, but thanks to Calvin for letting me use it because I don't have one at my house. Okay, let's make this straight. I missed my Surface Go. Okay, so where am I? Why are there 2 of these? Let's just cut this off. Okay, so let's take the derivative. There's no j here, so it's going to be 0 automatically. Get out of here. Okay, then 2. Wait. I realized that I forgot a V here. I knew something went wrong. Yeah. So I'm going to take the derivative to get rid of this. All right. Oh, and I also don't need this. No more summations for this because of the derivative. Okay, so bless you. So what we're going to do is, bam, gone. U A V. I'm not going to put a J there. Okay. So then for this next part, you have multiple cases. You have a case where, I'm just going to write it down here. your P is equal to J, and your Q is equal to J. Or why did I write 0? Equal to J. And you have one where P is not equal to J, and Q is not equal to J. And then you have one where P is equal to it, but Q is not equal to it. P is not equal to it, and then Q is equal to J. Right? So when you do this, you're going to get rid of one of the things. So I'm going to do. You're gonna have, oops. You're gonna have one where you have everything in there, right? So you're gonna have like, well, actually, you're gonna have one where you have 0. But you're also gonna have one where you have the CP, but not the Q, and the U. Oh, ew, it's so gross. I hate this. Okay, so then the U. E dot product. Probably should have put the dot there instead, but it's okay. And then, oh yeah, sigma plus, and then like the opposite, right? Your CQ. This is so disgustingly hard to write. Okay, and then your UQ. But for when Q is not equal to J and when P is not equal to J or something. Hope I put those on the right spots. And then you have one where you have everything. Yes, I realized I made a mistake. It is not CP, it is CJ. So this is when it equals J. And then you have, oh yeah, let's not forget our dot. Our dot. I'm pretty sure the dot's supposed to be there, not there. But handbrake. Okay. CJU. I think it's 2 UJs because this is when it equals the UP and the UQ at the same, or J is equal at the same time. I'm just going to erase this. Okay, not sure why it didn't erase when I had it on there. So then I'm going to explain. So we have this gap when Q does not equal J, and this gap when P does not equal J, and oops, in both of these areas. But this right here plugs it in for these, so there's no gap in your summation, so you just have two full summations, right? And so your derivative is going to be equal to the 2U dot product. Oh, it's so disgusting. What have I done? I feel like singing the yeah, this is like vectors. There's not a camera over there. It's over there. Okay, so you have two complete summations, right? And so you have your plus, ew, gross. But oh yeah, I was saying that I felt like singing the Hunchback of Notre Dame, and I am ugly for my work. Okay, so two summations, right? And so since it's everything combined, the P's, Q's, J's, whatever, I'm just gonna use I again because ew, wait a second, but that's J over there. So I'm just gonna let's make everything I. Shh. Reality can be whatever I want. Okay, so we're gonna have our CI and then our UI dot product UI. Ooh, isn't it so pretty? But as you can see here, we have the two twos. You can like cancel that out. And the summation, since, am I forgetting something? No, but I think this is J. And these were going to be J's. Ooh, that was a pretty J. Okay, but basically all the CIs line up with the UIs. That way the summation really doesn't really matter anymore. And you do the same algebra as you did earlier, where you say, oh, well, our CI or whatever, C whatever it is equal to, because you put this, or, gross. Let's minus the, put this on the other side. And then you have your V vector dot product your U vector over, over, and then these ones right here. That's why it didn't make sense. It's a minus right there. It's a minus right there. I messed up right here. Because it's 0 and then minus. See, because VV, that one, and then it's minus right there, right? But for some reason, I put a plus sign. So now it makes sense to plus that on the other side and then divide this right here, the V dot product, the U, by the U dot product, the U. Ooh. And then we go and we look. Oh, wow, it's the same. It's the same. And you've minimized your sum square error by setting the derivative equal to 0. And you've done it doing this process instead of the one from part A. Let's go to part A, take 2. See? And now I can stop recording.